session, right. So, in the last session we discussed about the root locus and we had seen a very few example of root locus, right. So, today we will see in detail example of root locus, what are the basic steps, right. So, we will see in detail today. So, in today's lecture we will discuss about the example, then we would like to see what would be the effect of addition of pole in the system, and then we would like to understand the concept of angle of departure and angle of arrival with respect to the root locus, right. So, first we would like to consider some special case, then we will move towards the example. So, first is here what will happen whenever our number of poles are equal to number of zeros. It means we are talking about here a perfect transfer function. It means G s would be given as suppose s plus 2, s plus 3, and in the denominator I am getting here s plus 1 and s plus 4. It means I am getting the equal number of poles and 0, then what will happen, right. So, in that case if I am going to calculate the centroid, so what I will get p minus z in the denominator. In the same way, if I am going to calculate here the angle of asymptote, so what I will get here in the denominator 1 over p minus z, and here if you calculate p minus z, that is n, which will tells you number of poles terminating to the infinity, it is 0, right. So, in this case our centroid and angle of asymptote is not defined, right. We need to keep in mind whenever our number of poles are equal to 0, in that case these 2 points are invalid. Okay. Now, what would be the root locus? So, for example, if I am getting a pole location in 0 like this, right, and here I would like to look for my valid region of root locus. So, you will find that whenever I have to look here the number of poles, that is odd or even. So, I will find here that this one would be my valid region of root locus, and we can say this one would be the valid region of the root locus. Okay. Because if you stand here and you have to look to your right direction, right, that you have to find number of pole is odd, it means this region is valid, because this concept we discussed in the last lecture. So, it would be clear how to calculate valid region in the root locus. Okay. The same way if I am standing here, number of pole count is 2, that is even. So, in that case we do not prefer this region, then we will stand here again, we will calculate number of poles and 0, it is 3, that is odd, it means this region would be a valid region on the root locus. Okay. So, after determining this we can say that our n is equal to 0, it means our pole is not terminating at infinity. So, where they will terminate at zeros. So, I would like to know what is the value of k here. So, here value of k is equal to 0, here value of k is equal to 0, because our root locus starts from open loop pole. We had seen this concept in the last lecture, and then you can see this is a 0. If I determine the value of 0 here, k value is infinity, and here I will determine the value of k, you will get k equal to infinity, right. It means this is the value where our root locus will terminate, right. So, initial value is 0 and initial value is pole and terminating value is here 0. Now, we would like to draw this root locus. So, here for clarity I will draw a different diagram where 2 poles are here. Now, these 2 zeros are here, this is my valid area. So, what will happen, these 2 pole will try to move towards each other, and this point you will get a breakaway point in between these 2 pole. Okay. So, they will move like this and they will approach towards the 0. In the same way second pole will come from here and try to approach towards the zeros, right. So, they are moving like this, and one pole will move toward this 0 and you can say towards right hand side, second pole will move towards the left 0 and it will terminate. So, when you calculate here breakaway point, so you will get here 2 value of breakaway point, one in between these 2 pole, one in between these 2 0. So, whenever this point is coming in between 2 pole, we are saying it is breakaway point. It is breakaway point. In the same way, whenever same point is coming in between 2 0, we are saying it is break in point. Right. So, here our root locus will terminate at this 2 0, and this would be our root locus for this type of system. Okay. So, we can analyze here the breaking point always come in between the 2 0, whenever our root locus approaching from complex plane, again returning back to the real plane. Okay. In the same way, whenever our root locus leaving the real plane, that point is known as breakaway point. Its reverse, whenever it is approaching toward the real plane, this point would known as breaking point. Right. In the same way, we can take one more example, right, where we will get 2 pole and 1 0. So, here my number of open loop pole is 2, number of open loop 0 is 1, and I would like to calculate number of pole terminating to the infinity and equal to p minus z is equal to 2 minus 1 equal to 1. Right. So, whenever my number of n p minus z is 1, what about phi? Phi would be our 180 degree. Right. We calculate the angle of asymptote from 2q plus 1 over 180 multiplied by p minus z. Okay. So, by this formula you can calculate the phi would be coming here around approximate 180, right. You can look for this formula from the previous slide, right. So, this is the value of phi here. Now, what would be you can say the movement of pole around here. So, if you calculate the breakaway point, it will come in between these two pole. Okay. So, here we are getting the single pole. So, what is the value of k? Value of k is here infinity. What is the value of k? Value of k is infinity. What is the value of value of k is 0 here. In the same way, value of k is 0 here. What is the value of k? Value of k is infinity. So, here n is 1, it means my one pole is going to terminate at infinity. Okay. So, here this pole will approach towards the breakaway point, this pole will approach, you can say this pole will move towards the breakaway point. Whenever they meet at breakaway point, overlapping of both poles will takes place, then one pole will come in complex plane, right, and they will try to touch the real plane and terminate to the 0. Okay. So, one pole will move in complex plane like this and terminate at the 0. In the same way, second pole will come like this and it will try to terminate or try to come at the real plane. Okay. So, this would be path of second pole. Now, when it arrives at this pole or at this position, what it will do? It will seek the location of next 0, right. So, here 1 0 is available. What would be the location of second 0? You can say it is infinity, right. For example, your G s is given as s plus 1 divided by s plus 2 s plus 3. So, what it means? It means two poles are here, 1 0 is here, then second 0 would be available at infinity, right. So, by assuming that we need to see this second pole which is coming from the bottom, it will approach to the infinity. How it will approach to the infinity? This direction is given by phi, that is 180 degree. Okay. So, this I think this will 180 will come here and p minus z will come here. There is a mistake in the formula. Okay. So, if you do this calculation, you will get phi equal to 180. Okay. It means in the direction of 180, my pole will terminate to the infinity, right. So, you will find this point is again breakaway point, and this point is here. Whenever both poles are meeting again, this is the break-in point. So, you can summarize one concept: breakaway point always exists between two pole and break-in point always exists between two 0. One 0 is here, second 0 is at infinity, minus infinity, right. So, break-in point always exists between the two zeros. So, this concept we have to look in the root locus. So, now we will see this numerical. A negative feedback control system having an open loop transfer function G s equal to k over s s plus 2. we need to draw the root locus and determine the value of k if damping ratio is to be 0.707. You can make it here 4 only for solution. Okay. So, our GS is given as here k over s multiplied by s plus 4, and then we need to calculate the value of k for this transfer function with the help of root locus. Okay. So, there are alternate way to calculate the value of k, right, but here we are studying the root locus. So, we will see how with the help of root locus we can determine the value of k. So, first step is we need to draw the root locus. Okay. So, I need to take the number of open loop poles. The number of open loop poles, you can say one is here 0, second is here -4, right. Then I need to calculate number of poles terminating at infinity. So, n equal to p minus z, number of open loop pole is 2, number of open loop 0 is 0, this will be 2, right. It means our 2 pole is going to terminate at infinity, right. Third case, we would like to see what would be the direction of this pole that it will terminate to the infinity. Okay. So, in that case we need to calculate phi given by 2 q plus 1 multiplied by 180 divided by p minus z. Okay. So, here I need to calculate the phi on the value of q. So, here my n value is 2, it means my q value would be 0 and 1. If my n value is here 3, then q value would be here 0, 1, 2. If value of n is 4, then q value would be here 0, 1, 2, 3. So, this is the way we determine here the value of q for calculation of phi, that is angle of asymptote. So, here we will put this formula and we will get q equal to 0 and 1. When q equal to 0, we will get 90. When q equal to 1, we will get 270. Okay. So, you can put it. So, here whenever you put here p minus z equal to 2, this will be 180 by 2, it will gives you 90. In the same way, when you put here q equal to 1, so this will be 3 multiplied by 180 by 2, which will gives you around 270. Okay. So, in this way we are getting the angle of asymptote. Now, we would like to see the valid point on the root locus on the basis of this transfer function. Okay. So, one pole is at origin and second pole is at -4, and if I determine here value of k is 0, if I determine here value of k is 0, it means this is my initial point of root locus. Okay. Now, if I look for valid reason, if I am standing here, so I can see towards my right hand side single pole is present, it means number count is odd. So, this whole region would be a valid region of the root locus. Okay. So, this is our valid region of root locus. Now, we need to calculate here centroid point. Where should I plot my angle of asymptote? It is given by summation of p minus summation of z over p minus z. So, it will be given by summation of p all the pole. So, one pole is at 0, second is at -4, minus zeros are absent, divided by p minus z, p minus z is 2. So, I am getting here this value is -2, right. So, this would be our point number 5, this would be our point number 4, step number 4. The same way we need to calculate the step number 6, we need to calculate here breakaway point. So, for calculation of breakaway point, I need to equate 1 plus G S H S equal to 0. Okay. So, here I will put 1 plus k over s multiplied by s plus 4 equal to 0. Now, solve it, this will gives you s square plus 4 s plus k equal to 0, equate in terms of k minus of h square plus 4 s. Now, calculate dk by ds. After calculating, you are getting here minus of 2 s plus 4. Now, equate to 0 to calculate the breakaway point, and you will get here value of s equal to -2, right. So, here our breakaway point would be -2, and centroid point is minus 2. It means if this is my point minus 2, so I will plot one angle of 90, then I will plot here angle of 270. Okay. This would be for 270 and this would be for 90. It means in this direction our pole will approach to the infinity, right. Again my breakaway point is minus 2. It means at this point both the pole will meet together, overlap with each other, and one pole will go towards the angle of 90, second pole will go towards the angle of 270 and reaches to the infinity. So, here the pole sitting at origin, it will move towards the breakaway point at minus 2. After arrival to the breakaway point, it will take the path of 90 degree and then it will move towards the infinity. In the same way, pole sitting at minus 4, it will move towards the breakaway point minus 2, overlapping with the pole, and then it will move towards the angle of 270 and then it will move towards the infinity. So, angle of asymptote will tells you in which direction our pole have to be moved. Okay. So, this is our root locus, right. Now, we would like to see the value of k for which zeta is 0.707. So, we know that zeta is given by cos theta, we had seen in unit 3, zeta is given as 0.707 equal to cos theta, or I can say it is 1 by root 2 equal to cos theta, and I can say from here my theta is equal to 45 degree. Okay. So, it means if I draw here a angle of 45, so you can say there would be a angle of 45. Okay. So, I need to determine here the value of k for it. Okay. So, suppose this meeting point is here something. So, what would be this meeting point? You can say this point is minus 2 in the x axis, you can say this is a triangle. So, this distance is 2, slope is here 45, it means symmetrical slope or symmetrical thing will available in the y axis, it means this point would be 2. The meeting point would be here, you can say 2j, you can say this point would be 2j because slope is here 45, right. So, now we would like to know the value of k for it. Okay. So, how we can calculate? So, we need to determine the distance of this point, you can say this angle is cutting at this root locus. So, I need to calculate length of pole, right. So, I need to calculate this point distance from pole at origin, I need to calculate distance of this point from pole at minus 4. So, if I calculate LP1, so this will be given by under root of 2 square plus 2 square, this will gives me under root of 8. The same way, if I calculate this distance from here, this will gives me LP2. So, it is given as you can say LP2 same as root 8. Then the value of k, you know that it will be given by LP1 multiplied by LP2 divided by length of 0, but zeros are absent. So, we can say value is 1. So, this will be root 8 multiplied by root 8 equal to 8. So, value of k is coming here 8. This is the one method. Alternate method is you can determine the value of this pole, you can say from magnitude condition, it is s over s plus 4. You need to calculate mod at s equal to, you can say minus 2 plus 2j. So, put the value of s, that is minus 2 plus 2j here and equate to the 1, then you can find out the value of k also. If you do this method, so you will get here value of k is equal to 8. So, both the method can be used to calculate the value of k. Okay. So, our next example we will discuss in the next lecture. Okay. So, thank you for today.